For years, the Creality Ender 3 was by far the most talked about and recommended 3D printer for those just starting out. Over the past few years, with the rise of ultra-fast machines and more options than ever before, the Ender 3 has begun to fade away from the forefront of 3D printer discussions. But with the latest addition to the Ender series range, that might all be about to change. Even with specs that are comparable to some of the most high-end 3D printers available right now, this machine comes in at a fraction of the cost. Which begs the question, could this be the next best 3D printer for beginners? Today is a very exciting day because we have a new 3D printer to try out. I am especially interested in this machine because I think that this could be a great option for somebody that is just starting out with 3D printing. Or, you know, the rest of us that can never just have one 3D printer. This is the Ender 3 V3KE that Creality very kindly sent over for me to test out. And this thing has some amazing specs and features on it. One of the most notable being the price. This printer is under $300 US, which is significantly less than a lot of other machines that have similar, if not identical, specs. And with that lower price tag, it already makes this machine more beginner friendly in my opinion, or at the very least makes the possibility of 3D printing a lot more accessible. So with all that being said, let's actually start unboxing this thing while I get into some more specifics about this 3D printer. The Ender 3 V3KE can print up to 500 millimeters a second, has a direct drive extruder, a filament runout sensor, automatic hands-free bed leveling, and a build volume of 220 millimeters by 220 millimeters by 240 millimeters high. The nozzle can reach temperatures of 300 degrees Celsius and the bed can hit 100 degrees Celsius. It also has a PEI flexible build plate and a touchscreen display. I know that might sound like a bunch of nonsense to anyone that's just starting out with 3D printing, so we're going to stop there with all of the specs. Ultimately, what matters with any printer is if it prints well and how the user experience is to get the machine up and running. In the V3KE's case, there is a little bit of assembly required, which is pretty typical for this open-framed printer design. There are about 10 bolts that you need to install, and most of those are going to attach the upper printer frame to the lower base. There's also the screen and spool holder to install. There are pretty clear instructions that come with this printer, which is awesome. It's a fairly straightforward process. There are a few cables that you need to plug in, but it's definitely been significantly simplified compared to what printer setup and installation used to be like. The final step is to plug in the power cord, and then we can turn this printer on to continue with the setup. The first prompts on the screen are the fairly typical select your language, time zone, connect it to your Wi-Fi network if you'd like, and from there it automatically starts its test calibration. So it heats up the nozzle, the bed, it cleans off the nozzle to make sure that there is no filament accidentally attached to it before calculating the Z offset, and from there actually just going in to probing the entire bed to level it. And I will say I was pretty impressed with how automatic this setup was. I did not touch the printer at all, and it was fully set up, calibrated, and ready to roll. Once everything was calibrated, it was time to get something printing. You all know that I refuse to break my benchless streak, so we're going to be jumping right in with pieces for a full-size Mandalorian helmet, and I used the Creality print slicer for this. I also just used the standard Hyper PLA profile. The only changes I made to it were the infill and wall settings, which is a pretty typical thing to customize depending on what you're printing, but temperature, retraction, any of that, I left it at the default to see how it would perform sort of straight out of the box if somebody just went into the slicer, wanted to hit print, how that experience would go. And I will say it was a pretty positive result. The only thing is, for some reason, on the default Hyper PLA profile, they have it set to like the high end of the temperature setting for the Creality Hyper PLA, and it's way too hot, which is unfortunate because like all of the other settings seem perfect, and to be honest, this is not a terrible looking print, but that uneven, wrinkly, wavy texture is fully due to this PLA printing at a way too high temperature. So for the next piece, I decreased the temperature about 10 degrees, and the inside of this looked absolutely flawless, but I still felt that it was a bit too hot. So finally, I was around like the 205 degrees Celsius mark, and these prints started to look incredible. Now this is somewhat a very particular filament to settings combination that somebody might not run into depending on what filament they're actually using, but it is something that I wanted to mention because once I downed that temperature, all of these pieces started to look absolutely flawless. Here we have all of the Paz helmet pieces. I believe all of this was done in just over 24 hours, which is around the time to be expected for these ultra fast printers. They're crazy fast. You can pump props out so quickly nowadays. I haven't taken any of the support material off or anything so that I could show you the pieces raw, sort of like straight off of the print bed. The only piece that I had to split was the dome to fit on the V3KE, which, you know, really isn't bad. This is going to be a super easy attachment to each other. It will go like that. And before I start cleaning up these pieces, I just wanted to talk a bit about the print quality and what I've observed looking at these pieces and what I think of them. So the first piece was, of course, the back piece. This piece doesn't look terrible by any means, but I can just tell that it's just printing way too hot. This piece could look so much better if the settings were just a little more dialed in. Thankfully, that's like a super easy fix. You know, that's a slicer issue, not an inherent printer issue. It's just unfortunate that the slicer profile is so off, and, you know, if a beginner just didn't touch any of the settings, for the most part, like every other setting, like retraction, speed, all of that looks flawless. It's just the temperature that is holding this piece back from looking phenomenal. But, you know, showing you here now, I'm sure a lot of you are probably thinking, you know, that doesn't look too bad, and it really doesn't. It just, when you compare it to something like this dome piece, which besides the whole texture, which is a whole other thing, this piece might have printed a bit cool. I was trying to test like the structural integrity by like literally trying to break the pieces, and they do seem to be quite well melted together, even though this one is a lot more matte than this piece. This still, in my opinion, is just way too hot compared to this one. Was printed around 205 Celsius. This was 230. I did also just want to mention, this is the textured version of the helmet, so when you see rough edges like this, it literally is supposed to have that. That's not like a printer malfunction or like a slicer problem. It literally is like chipped and bumped, and like you can see the like dings in the scratch marks and stuff in the helmet. But once I realized the temperature thing, these pieces started turning out beautifully. Like you can just see the surface quality and also just like the definition of the different like recessed details and scratches and nicks and stuff that are all in like the mohawk brim area. Also the overhangs on these pieces, it really does not get much more clean than that. You can also see on the front here just how extreme that overhang is. It of course printed like this, and right in here, that's a pretty extreme overhang, and it looks really clean. So the cooling on this printer is phenomenal. I'm really happy with how these pieces look overall. Again, it's one of those things that because there's like so many dings and stuff in this helmet, maybe I should have printed the clean one for a better example, but I did also want to see if it would actually do the little nicks and details and stuff, and it definitely did. Of course, the next test is how these supports break off. And you can see that is a pretty clean support removal, despite once again being a pretty intense overhang. And of course, all of the earpieces have significantly finer details. Of course, it's more paneling details, and all of those look really clean as well. I'm going to go ahead and start cleaning off the supports on all of these pieces, and also probably get this helmet into one piece. The supports were removed really easily and cleanly. I don't want you to think that my busting out of various pliers and tools was because it was difficult. It's just a lot easier to get into the small areas and clean those out with the tools. Same reason that I'm wearing gloves, because if you've ever removed support material from a 3D print, you know that it will cut your hands up like no other. Now, typically I would not assemble this helmet until I had a chance to do some sanding and post-processing on it, but for the sake of this video, I did actually glue the 4 main helmet pieces together, which I will say was not the prettiest assembly job I've ever done, but we'll fix that later. For the earpieces though, I just either pressure fit them or use some poster tack to keep the pieces stuck together so that I could just put them on the helmet for the sake of this video, and then of course they will actually get assembled later on once I have a chance to work on this helmet a bit more. I've spent the last week or so really trying to put the V3KE to the test, so I figured we would sit down and discuss what that experience has been like and just generally my thoughts on this printer. Clearly we have a new Droid friend, which I was originally just going to print his head, but I figured doing the entire Droid would actually be quite a good test for this machine because the pit droids tend to be a beginner droid project, so that sort of fits in perfectly to the theme of this being a possible great beginner printer. And also the various pieces on the pit droid, you have a mix of a lot of different shapes to really be able to see if anything sort of tripped up this printer, you know, like if it had an issue doing cylinders or more straight lines or any of that stuff. But by the fact that I do have a new Droid friend, it probably tells you that this machine handled these pieces perfectly. I printed this pit droid in PETG because I wanted to try a different filament, and just generally I tend to not print any of my droids in PLA just because if I ever want to take them to conventions or just any of that, they have a little higher resistance to any wear and tear and temperature, and just generally PETG tends to be a little easier to finish, so I was trying to save myself some sanding time in the future. But most of this guy's pieces looked excellent. I did experience one weird issue that I wanted to mention here. It wasn't the printer's fault, but it's something that I feel like could possibly come up if anybody has this printer or is considered looking into it, so wanted to mention it. When I flipped the materials, I of course ended up flipping the slicer profile from the PLA one that I was using to something that was labeled PETG, and then made any personal tweaks that I wanted to from there. But when I did that, there started to be these artifact lines or moire lines all of a sudden appear on the pieces, and at first I thought it might have been vibration, but it was really weird, and I printed a couple of pieces and the lines were way too uniform. The types of lines that it was creating tend to be caused by like electrical or mechanical issues and not so much vibrations, and that made no sense considering none of those lines showed up on the helmet, and it's something that doesn't just appear basically is what I'm getting at. And so I was trying to think what on earth was going on, and I realized that the only thing that I had changed was the slicer profile. So I don't entirely know why it did this, but I ended up going back to the PLA profile that I used for the helmet and just tweaked the temperature settings and cooling settings to match what I wanted to use for the PETG, and all of a sudden the lines magically disappeared. So I unfortunately have no idea why it started happening other than the slicer profile for whatever reason was the cause of it. That was also an Orca slicer because I did start using the Creality print software that is generally recommended to use with this printer for the helmet, which it was great. It's very simple. I think it's a very good beginner-friendly slicer software. It's really not complicated, which is ultimately why I decided to switch, because it was a little too beginner for me. You know, I'm used to having a lot of like microcontrol with all of my print settings, and even if I don't really switch anything, I just generally like being able to see what on earth is happening. So for me, it was a little too beginner friendly, but for anyone that is possibly going to get this machine as a beginner printer and is using that slicer, I think it's very beginner friendly. It's not overwhelming, which is a big thing that can happen when you start 3D printing, is things can get very overwhelming very quickly with all of the new stuff that you have to learn, and it's a very straightforward software. So great for beginners, not great for somebody who's been 3D printing for over 5 years. But overall, I think this pit droid's pieces look excellent, and considering this is like such a low hassle machine, I do just want to mention that I did not have a single print failure whatsoever in the time that I was printing all of these pieces, which was a pretty consistent like 5 to 7 days of almost non-stop printing. Like this printer, this is almost almost the first time it has been shut off in the last week, and I didn't have to adjust the leveling that it automatically did itself once. Zero manual leveling whatsoever. It probes the bed. The default value that it had for Z offset was set perfectly in my opinion. I didn't have any issues with adhesion to the bed. Everything stuck where it was supposed to be, sometimes even a bit too well, but that's more of the like PEI and PETG combination. And like a lot of current printers on the market, this of course can be connected to Wi-Fi, so you can remotely send prints to it, and you can also connect it to the Creality Cloud app, which for what the Creality Cloud app is probably marketed for, I don't use it for at all, but what I do like connecting my printers to their apps for is because you can set it up that they notify you when the print job is finished, which is very handy when you're trying to print Droid pieces in as fast a time as possible so that there's no wasted time in between print jobs. And of course also means that you can remotely heat up the printer, which I've done as well. Just like, you know, I'm making my way to the workshop, might as well get the bed heated up so that I'm not sitting around here waiting for it to do that by the time I get here. So while you can use the app to send prints to your machine, that's not what I personally use it for, but that is a feature that quite a few people could be interested in since it is so convenient to just be able to send prints from your phone. So overall, I do think that this would be an excellent beginner printer. It is by far the best Ender 3 that I have ever used. I have 3 other Ender 3s that I've had for quite a few years at this point. They have been probably my most used machines, even though I know you don't necessarily see that a lot on video. I mean, you've probably seen me print different Droid parts off on them, but I've clocked like thousands, if not hundreds of thousands of hours on Ender 3 printers, and mine have extremely heavy modifications to them, which this machine already has included basically all of the upgrades that I have done to mine over the years, and this printer is the least expensive Ender 3 of all of them, and it has already all of those upgrades, which is pretty crazy. And of course it can print like 3 times as fast as any of those. So if you are someone that has been looking at one of the Ender 3 machines, then I would say this one is possibly the one that you should be considering getting. There comes a point where the upgrades between the older and newer models are worth significantly more than any price difference. In fact, some of the older models probably are more expensive than this printer, even though this one arguably has the better features on it, or at least the same ones. But of course, then it prints way faster. Something that this printer doesn't have, which I was a bit confused about in the beginning, is vibration compensation. It's a pretty standard feature on most ultra-fast machines because it kind of needs it. You know, when the machine is printing at such a high speed, it can just very easily create those vibration lines, and it's something that you want the machine to compensate for so that you don't have any visible artifacts on the walls of the print. And what's also slightly annoying is this printer does have the capability of having vibration compensation. You can additionally buy a sensor to be able to calculate the vibrations, and when I was looking into this, it was like, why wouldn't they just include the sensor if it was such an inexpensive upgrade to begin with? But the only thing that I can think of that makes me moderately okay with that decision is basically if you are considering this printer to be something that's incredibly beginner friendly, the idea of having this additional sensor to have to deal with and figure out is possibly more hassle than a beginner wants to deal with. So that is the only thing that makes me possibly okay with the decision to not include the sensor and the vibration compensation immediately with this machine, other than the fact that for the most part, none of these pieces look like they're suffering terribly with any vibration lines on them. I had the walls on all of these prints printing pretty fast. I was doing 300 millimeters a second for the inside walls and 200 for the outside, which is pretty crazy fast. It is faster than I would maybe typically consider doing walls even on ultra fast machines, since the walls are what will show the vibrations the most. But those are the default settings for the PLA profile, and I wanted to see how it performed. It's again one of those things where a beginner isn't going to start messing with the speeds, so let's see if somebody was brand new to 3D printing, how they would use this machine and how successful those prints would be. So other than the unfortunate temperature settings for that profile, all of the other settings seem to have worked very well. Really, the only limitation that this machine has is going to be its build volume. There was, of course, that one helmet piece that just didn't quite fit. But for a beginner printer, you know, you might never really be looking at printing things this large, and the majority of pieces had no issue whatsoever fitting on this machine, and it's obviously something that can be pretty easily rectified by just splitting the different pieces down that might not quite fit on the bed. But yeah, I had a great experience with this printer. I think it definitely checks a lot of the beginner-friendly printer boxes. Great price point, very low hassle, just to print and leave it, and it just works. This machine is also going to have one of the added bonuses that I always like to mention, which is a lot of community support. Obviously, a ton of people have Ender 3 printers. A lot of people will end up having this machine specifically, so if you were to ever run into any questions, you will most likely be able to get an answer or find an answer somewhere online. That is one of the biggest bonuses that you can have with printers as someone just starting out, because if you end up with a machine that no one has ever used and has never heard of, no one's going to be able to know how to help you if you were to ask a question on a forum of some sort. So that is the popular printers bonus benefit that comes in very handy as a beginner. Yeah, I'm a big fan of this printer. It's pretty crazy that all of the features that it has and the print quality that it can produce can be at such a low price. That's not me complaining. I'm glad that something like this can exist at a more reasonable price point. It's just a really low maintenance, no hassle, easy machine to use that gives really, really nice prints off of it. So if you are someone that's been looking to getting into 3D printing, then I definitely think this could be a great option for you. Thank you again to Creality for sending over this printer. But that is everything, so thank you so much for watching, and I will see you in my next video.